So this is a continuation of number 82 from section 0.1. For starting on part D, one thing I suggested in the previous video was to write out what these numbers are and see if you can see a pattern in there. So I'm going to go ahead and do that. So 1 minus 1/2 is 1/2. 1 minus 1/3 is 2/3. 1 minus 1/4 is 3/4. 1 minus 1/5 is 4/5, and so we have this pattern that continues. Later we would have 10 over 11, later we would have 99 over 100, etc. And hopefully what you notice is that these fractions are getting bigger, but they're not going to get bigger than a certain number, okay? And you probably can tell what that number is already. If not, I'm going to talk about it a little bit differently. Another way to think of this is each number is 1 minus 1 over n, okay, where n is an integer, okay, and as n gets bigger, okay, because we've got 1 over 2, 1 over 3, 1 over 4, 1 over 5, etc. As n gets bigger and bigger, 1 over n, let me write that differently, okay, as n approaches infinity, then 1 over n will get smaller and smaller and smaller, or in other words, it will approach 0, okay? So eventually, as n is going to 100, or not 100, sorry, to infinity, we're going to have 1 minus 1 over a very, very, very large number. So I'm just going to write large number here, okay? But this number approaches 0, meaning we're getting closer and closer and closer to, or let me say, not equal to, I don't want to say that, but I'm going to say that this approaches 1, okay? So the least upper bound for part D is 1, okay? For part E, again, I'm going to write out some, all right, I'm going to write out some numbers. So for part E, this means the set of x, and then the colon right there means such that. So this means x, the set of x, such that x is equal to negative 1 to the nth plus 1 over n, where n is a positive integer, okay? So writing that out, it's going to be negative 1 to the, in positive integers, we're starting with 1. So negative 1 to the first plus 1 over 1. Okay, and I'll simplify that here in a second. And then negative 1 to the second plus 1 over 2 when n is 2. And then negative 1 to the third plus 1 over 3. Okay, let's see what these numbers are. So we have negative 1 plus 1 is 0. Okay, and then negative 1 squared is positive 1 plus 1/2 is 3/2, or 1.5. Negative 1 to the third is negative 1, so negative 1 plus 1/3, okay, which is going to be negative 2/3. All right, at this point, we can see a pattern here. The negative 1 to the nth is going to be flip-flopping back and forth between positive and negative 1, okay? Anytime n is an even number, an odd number, then the first part is going to be a negative 1, meaning we have a smaller number. Since we only care about a least upper bound, I'm going to ignore all of those. So really I'm just going to look at when n is even, okay? And so when n is even, that starts with, sorry if you hear a dog growling, shh, that starts with 3/2. The next one would be 1 plus 1/4, so it's going to be 5 over 4, okay? And these numbers, since just like on the last one, we're adding a smaller number each time, we can see that same thing happening here. That means this number is going to be the highest number in the set, so our least upper bound is 3/2, okay? And then for the last one, part F, okay, we have the set of x such that x squared is less than 2 when x is a rational number, okay? So this kind of brings a little bit of discussion about another problem that you have about having rational numbers. You know, between any two rational numbers, there's an irrational number. Between any two rational numbers, there's an irrational. I can't remember which one I said first, but there's always because we have an infinite number of numbers inside any amount of space, there's always, between any two numbers, there's always another rational and another irrational number. Now, technically speaking, and this is something where I wish that I was in front of you to answer questions, but technically speaking, there are more irrational numbers than rational numbers, but there's an infinite number of both. Okay, so when this one says the set of x such that x squared is less than 2, the first thing I want to do is think, well, if x squared is less than 2, then that means, okay, if x squared is less than 2, then that means that x has to be between negative root 2 and positive root 2, okay? And we only care about the upper bound, so I'm actually going to ignore this bottom side, and I'm going to look at this right here. So x is less than root 2. Now, x cannot be equal to root 2. In other words, root 2 cannot be an element in set S, but we just need a least upper bound. And remember, least upper bound means all of the numbers are less than or equal to. If we don't have a way to actually name what the highest number in a set is, then we pick the highest number that we can name. The lowest number that we can name that is above all of the numbers in the set. So here, root 2 is actually our least upper bound, okay? So is root 2 part of the set? No, it's not, but the least upper bound does not have to be an element in that set.